So today we're going to learn two more methods on how to solve our quadratics. The first one is solving using square roots. I think this method is like almost as easy as graphing, okay? How do you solve a quadratic equation using square roots? Our goal is to isolate the x squared term. What does it mean to isolate? Get by itself. We're getting it completely alone. We're getting our x squared completely by itself on one side of the equation. Instead of just solving for x, we're solving for x squared. Okay? What undoes a square? Square root. So then you're going to take the square root of both sides of the equation. Now, the only tricky part is you have to remember a positive number always has two square roots. It has the positive and the negative. Now let's think about why that's true. If you take the square root of 4, it's positive negative 2. Why? Because what's 2 squared? 4. What's negative 2 squared? What's a negative times negative? Positive 4. So there's two different ways to multiply something by itself to get 4. 2 times 2 and negative 2 times negative 2. So that's why whenever we take the square root, we're going to put this plus minus sign out in front. This means the positive number and the negative number. So anytime you see a plus minus, that's talking about two different numbers. Okay? It's just a shorthand way of writing. You could write 2 and negative 2, but plus minus 2 is just shorter. Now, I said I think this method is one of the easier methods. Well, then why don't we just always use this method? Okay, you only can use when there is no bx term. That is the only time you can use this method. You cannot have a bx term. You can have an x squared term and you can have a constant. You can't have an x term. Okay, so that's why this isn't like one of our most used methods, because normally it's in the form ax squared plus bx plus c. So normally you have an x term. Okay, but if you don't, I think this is the best method to do. Could you still graph these? Remember on day one I told you you can always graph. You can always graph. In order to graph, it has to equal 0. Okay, but you can always graph to check, and you always should graph to check. Okay? So, looking at this first one, do I have a bx term? No, I only have an x squared term and a constant. So there's no bx term. That lets me know I can use my square root method. Okay? Is the x squared all alone on one side of the equals? Yes. So the first step's already done for me. Step 2 is take the square root of both sides. So put the square root around both sides. What happens when you square root a square? The square root and the square undo each other. Just like adding and subtracting undo each other, multiplying and dividing undo each other, squaring and square rooting undo each other. Okay, so anytime you square root something that's squared, they cancel each other out, and I'm just left with x equals. What is the square root of 25? Now, if you don't know, you can go to your calculator and do the square root. Where is your square root button? It's the x squared button, but blue. So you have to do second x squared. And then type in square root of 25. And when you type it in, you get a whole number. Since you get a whole number, the square root sign's gone. But what has to go in front? The plus minus, because my answer is not just 5. It's plus minus 5. Because again, 5 squared is 25, negative 5 squared is also 25. So there's two solutions here. So I could write this as 5, 0 and negative 5, 0. And there we go. Could we check ourselves? Yes, okay, go to your calculator. Go to y equals, clear out whatever is in there. Can I put it in as it is right now? No, because it doesn't equal 0. So I'm going to type in x squared. How would you move the 25 over to be with the x squared? How do you move a positive from the right to the left? So minus 25. I'm moving my 25 from the right to the left. Good? Now I can graph it. How many times should it hit the x-axis? Twice. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 and negative 5. Good? Again, most common mistake when we do this is we don't put the plus minus. That's why it's a great idea to graph it on your calculator, because then you visually see how many solutions do I have? 2, because it hits the x-axis twice. Okay? Next one. Is there a bx term? I have an x squared and I have a constant. So is there an x term? No. So I can do this by using the square root method. So I'm going to solve for x squared. I need x squared by itself. What are we going to do to get x squared by itself? Add 100. Very good. Is x squared now by itself? So what do I do on both sides? Square root. Anytime you're trying to get a square off a variable, you square root it. So I get x equals plus minus 10. Don't forget the plus minus 10. We talked about this a little bit last class. Is it okay to leave my answer like that? Yeah. This is one of the two ways. You can leave it as x equals a number, which in this case x equals how many numbers? 2. Or you can write it as ordered pairs. If you write it as an ordered pair, what's always the y value? 0. Can we graph this to check? Yes. Is it already solved for 0? Does it already equal 0? Yes, we don't have to change anything. X squared minus 100. And graph. You can't really see, but you can kind of see part of it on the left and part of it on the right. Does it look like it hits at negative 10 and positive 10? Yes. If you wanted, you could zoom out and hit enter. Now do you see it hits twice? And then you could go back and do zoom standard. Good? Do we like this method? Way shorter than factoring, yes? Now again, the reason we can't always use this is because it's only limited, or it's limited to when you don't have a bx term. Okay, next one. Is x squared by itself? Yes, no? No. Solve for x squared. What are we going to do? Subtract 7 on both sides. And then I get x squared equals 81. And then what do I do next? X squared is now by itself. What are we going to do next? We're going to square root. The square and the square root undo each other, and I get x equals plus minus 9. Again, I'm going to write it as 9, 0 and negative 9, 0. Could you just leave it as x equals plus minus 9? Yes. Good? Okay, we are doing a lot of practice with these guys, but they're slightly different. Like if you look at number 4, do I have a bx term? Do you have a bx term? No, I have an x squared term and a constant. There's no just x term. So So I'm going to draw my line through the equals. X squared isn't by itself. The x squared term is by itself, but I'm not saying I want the x squared term by itself. I need x squared completely alone. So what am I going to do to get the 6 away from that x squared? Divide both sides by 6. So then I get x squared equals 9. Remember, you divide by coefficients, you add and subtract constants. Okay, is x squared now by itself? What do I do? Square root both sides. Squaring and square rooting undo each other, so I get x equals plus minus 3. I'm going to show you a third option of how you could write it. Still as an ordered pair, but you could write plus minus 3 comma 0. That's an ordered pair, but I'm being a little bit more efficient / lazy. I'm not writing the ordered pair out twice because I can just put the plus minus. How many solutions do I have here? 2. I have the positive 3, 0 and the negative 3, 0. Just because I have one ordered pair written does not mean there's only one solution. There's still 2 solutions, positive 3 and negative 3. Good? So these are really your 3 different ways of writing solutions. Okay? Next one. Do I have a bx term? No. Draw your line through the equals and circle x squared. What are we going to do? Divide by negative 2. And we get x squared equals 49. What do I do to get the square away from the x? Square root it, and I get x equals plus or minus 7. Okay, next one. Draw your line through the equals. Do I have a bx term? No, I just have an x squared and a constant. Circle your x squared. What am I going to do first to solve for x squared? Add the 45. You get rid of constants, bless you, before you get rid of coefficients. So I'm going to add 45 on both sides. Drop down your 5x squared equals 45. I still need x squared by itself. So what are we going to do next to get x squared by itself? Divide both sides by 5. And we get x squared equals 9. Now x squared is by itself. What do we do to get rid of the square? Square root it. So I get x equals plus minus 3. So that's plus minus 3 comma 0. How are we feeling? Good. Next one. Is there a bx term? No, so we can solve it using square root method. Circle your x squared. What am I going to do to get x squared alone? Add 5 on both sides. Very good. So then I get x squared equals 1. What do you do to get rid of a square? Square root, and you get x equals 1 plus or minus 1. So that's 1, 0, and negative 1, 0. Again, guys, I am switching up how I am writing my roots, my zeros, my x-intercepts, my solutions, just to show you there are multiple correct ways to write your solutions. Okay, there are multiple correct ways to write your solutions. Okay, this last one's a little bit different. Same process, but the answer is going to look a little bit different. Okay? Do I have a bx term? Draw your line through the equals, circle x squared. I want x squared by itself. What are we going to do first to get x squared by itself? Add 49 on both sides. Good job. So then I get 4x squared equals 49. X squared is still not by itself. Let's do it again. Divide by, good job, divide by 4 on both sides. Divide by your coefficient. Is 49 divisible by 4? No. So it's just 49 over 4. How do you get rid of a square? Square root on both sides. So what happens with your square root and your square? Thank you. They cancel each other out, and I get x equals. When you take the square root, what do? What has to go in front of your number? Plus minus. When you are square rooting a fraction that doesn't simplify, square root the top, square root the bottom. What's the square root of 49? What's the square root of 4? So it's 7 over 2. Good? We liked that method, yes? I will tell you today, we are going from probably a method y'all like the most, / is the fastest, to least favorite method, okay? I will tell you this method I'm about to show you, you do not have to really ever use. On the test, you will have to know a little bit about this method, but this is a method you don't really have to use, okay? Okay, so this one is solving quadratics by completing the square. How do you solve a quadratic by completing the square? Okay, there's a bunch of steps, a lot longer than it was taking the square root of both sides, right? Now, why would I even show you this method? You can solve all quadratics with this method. That's why we do like this method, and you will use this in algebra too, so that's again why I'm showing it to you. Okay? Because when we're solving by graphing, you really need whole numbers or fractions. Not everything are whole numbers or fractions. Okay? Sometimes you have irrational answers, which means you're going to have to use completing the square. Factoring, it has to be able to factor. We did one last class that couldn't factor. Solving by taking the square root of both sides, you only can use that when there's no bx term. The next two methods, the last two methods that we're doing, one today, one when we come back from spring break, are definitely the least fun, but they're the two that no matter what you can always use. Okay? So, when we are completing the square, you're going to move C term to the right of the equation, so it's in the form ax squared plus bx plus, and I'm going to put a little box here because that's going to be what we use to complete the square, equals negative c plus the same box. So I moved my positive c from the left to the right, so I'm subtracting c. Move your constant to the opposite side. Okay, then we're going to find b over 2 squared. We call this your magic number. This is the most important part that you will need to know for the STAR test, because they do ask about, like, what's the number that needs to be added to both sides to complete the square? That's the magic number. So you need to know how to find the magic number, okay? And on your test, after spring break, on your test, you're going to have two questions that are like, what's the number that will complete the square? So this is the formula we use to complete the square. That we are going to call our magic number. Your magic number will always be what kind of number if you're squaring it? What'd you say? A fraction? Sometimes it will be. Positive. This is always positive. Your magic number is always positive. Why? Because any number we do in here squared is a positive number. Negative times negative, positive. Positive times positive, positive. So your magic number is always positive. Okay? So we're going to find the magic number, then we are going to add the magic number needed to complete the square to both sides. That's what the empty box is for. We're going to put that magic number in both boxes. Now, the thing I do like about this is when we are completing the square, we then have a perfect square trinomial. Remember, if you are able to identify you have a perfect square trinomial, it's super, super easy to factor. Here, you don't even need to be able to identify that it's a perfect square trinomial, because that's what we just made it. It will always be a perfect square trinomial. So when you're solving by completing the square, you will always be able to factor it like we are going to. So, factor a perfect square trinomial. So if you remember, that's the a squared plus 2ab plus b squared. And that's a plus minus, sorry. And that's equal to a plus minus b squared. Y'all kind of remember that? Square root the first, square root the last. Square root of the first goes first, square root of the last goes last, and you square the parentheses. The reason we have plus minus here is b tells you if it's a positive or negative. If you don't remember this, as we do them, it's going to come back. Okay? After we do that, we're going to take the square root of both sides of the trinomial, of the perfect trinomial, and the square root of the value on the right side. And then we are going to solve for both values of x. Again, when you have a quadratic, how many solutions do you have? 2. When can you use this method? Always. That's what we wrote up at the top. You can always use this method. And let's add though, a must be 1. Must be equal to 1. And if it's not, you can divide out the a. A must be equal to 1. Now all the ones we're going to do, one of them, a is not 1, but we divide it out. Okay? We ready? Sounds like a lot, guys. The great thing is you do the same exact thing every single time. Okay? So, step 1 is move the c term to the other side. So how am I going to move this negative 8 from the left to the right? Add 8 on both sides. So then I have x squared plus 6x plus blank equals 8 plus blank. Why am I putting blanks on both sides? For our magic number. Very good. We're adding the magic number to both sides. First step, not too bad, right? Okay. Step 2 says find the magic number. b over 2 squared. So over to the side, I'm going to write magic number. What's my b? 6 over 2 squared. So what's 6 divided by 2? Squared? 9. So this is 9. Then I'm going to add that number to both sides. That's what's going in the plus blanks. Now, what does the magic number do? It magically turns this into a perfect square trinomial, which now we can factor by doing parentheses squared. Remember, if you have a perfect square trinomial, it's just parentheses squared. The way we figure out what goes first, what's the square root of x squared? X. So that goes there. What's the square root of 9? That goes there. Do we remember this a little bit now, guys? Coming back to us? No? If it's not, that's okay. We're doing it 6 times today. And then your b tells you if it's a plus or minus, so it's a plus. Square root of the first term goes first, square root of the last term goes last. B tells you if it's a plus or minus. Equals, what's 8 plus 9? 17. So we just made it a perfect square trinomial. Good? Okay. Now it says take the square root of the perfect trinomial and the square root of the right side. The reason I can square root this is because I have one thing to the second power. If I square root it, the square and the square root cancel each other out. If you square root on the left, what do you have to do on the right? Square root. We okay with that? The reason you're allowed to do this is because the parentheses are squared. I want to get the parentheses unsquared, so I square root it. So now this is x plus 3 equals, what did we remember about the square root method that we just learned? What needs to always go in when you square root? So it's going to be plus minus. Can 17 be simplified? Sorry, the square root of 17? 17 is prime, so it's just going to say square root of 17. We okay with that? Then it says solve both, or solve for x. What am I going to do to get x by itself? Subtract 3. And I get x equals, are these like terms? Can I combine them? No, so it'd be negative 3 plus minus square root of 17. Do you see how this answer looks way different than when we graphed it, factored it, and took the square root of both sides? These answers are ugly, okay? That's why we can't do this by graphing, okay? However, can we check ourselves by graphing? Yes, okay. How many, or I'm going to write this out as negative 3 plus 7 square root of 17 and negative 3 minus square root of 17. I want you to type both those in the calculator and tell me their decimal equivalents. Because again, some of your answer choices might look like this. However, you can always use the calculator to check. So negative 3 plus the square root of 17. So this is like 1.123. And then negative 3 minus the square root of 17 is negative 7.123. Okay, so do y'all remember last class me showing you Desmos? And we said Desmos is way easier, right? So I'm going to type it into Desmos. X squared plus 6x minus 8. Okay? So I put my function right here. What's that decimal? Is that what we got whenever we typed it into the calculator? Yes. Over here. What do I get? So do you see how even though we can't solve it by graphing, you can still graph it to check? Good? Again, that's why we said graph, graph, graph. All of these you should be graphing, whether it's to solve or whether it's to check what you've already solved. So here is my answer. Good? Was this long? A little bit, but again, you're doing the same exact thing every single time. Okay? So, what's my first step? Subtract 2 from both sides. So I have x squared plus 6x plus blank equals negative 2 plus blank. What's my next step? Find the magic number. Your magic number is that formula, b over 2 squared. What's b? Over 2 squared. Guys, it's just a coincidence that my magic number is the same. Don't think your magic number is always 8, always 9. It's not. So this is 9. Add 9 on both sides. Okay. Then we are going to factor our perfect square trinomial. So I do my parentheses, squared. What's the square root of x squared? What's the square root of 9? Is it a plus or minus? Equals, what's negative 2 plus 9? 7. Great job. What are we going to do next? Square root both sides, because I need to get rid of the parentheses squared. So they cancel each other out, and I get x plus 3 equals what? Say it a little louder. What goes in front, though? Plus minus square root of 7. Can the square root of 7 be simplified, guys? No, 7's prime, so you can't simplify the square root of 7. Okay, my next step is to get x by itself. What am I going to do to get x by itself? Minus 3. So I get x equals what do I get? How many solutions are here? This is 2 solutions. Even though it looks like only 1, it's still 2 solutions because one solution is negative 3 plus the square root of 7 and one is negative 3 minus the square root of 7, and they're going to give you different answers. Dead? How many of us after doing 2 are like, okay, this isn't that bad? Okay. How many of us are like, dear Lord, I would never want to do this? If that's you, which is okay, please just make sure you remember b over 2 squared is your magic number. Okay, b over 2 squared is your magic number. You never have to use this method. You never have to use this method. So if you hate what we're doing right now, that's okay, but you must know how to find the magic number, which is b over 2 squared. Okay? Okay. What do we notice about number 3? It doesn't equal 0, meaning the c is already on the right side. So I'm going to rewrite this, though, where I'm going to do my plus blank. Remember, you have to add that magic number to both sides. Okay? So how are we going to find the magic number? We're going to do, what did you say? Negative 6 over 2 squared. What's negative 6 over 2? Squared. Positive 9. Remember, your magic number is always positive because a negative squared is positive. Don't leave right now. Wait till we're done. So I add 9 to both sides. Add your magic number to bites. Okay, what do we do next? Factor it. Parentheses squared. What's the square root of x squared? What's the square root of 9? Is it a plus or minus? Minus. Equals, what's negative 3 plus 9? 3. How do we undo the square? Square root both sides. What color did I use for that? Purple? Purple. So the square and the square root undo each other, and I have x minus 3 equals Great job. Can you simplify the square root of 3? No. Okay. So what do I do next? And how do I do that? Add 3 on both sides. I get x equals 3 plus minus square root 3. I'm going to write this as an ordered pair, and I'm going to write it as 2 ordered pairs. 3 plus the square root of 3, comma 0. And 3 minus the square root of 3, comma 0. Guys, I know that this looks like it's 2 values, but it's just 2 terms. This is all your x values. So x, comma y, what's always the y value of your intercepts? X-intercepts? 0, okay? So these would be how you would write it as 2 different solutions, or 2 different ordered pairs. Good? Wait till we do finish notes. Guys, I want y'all to wait till we finish notes unless it's an emergency. If it's an emergency, then go. But if it's an emergency, always go. But I'm just saying, like, some of y'all just leave every day during notes, which is a bad idea. Okay, next one. What should I do first? Add 8 on both sides. And I get x squared minus 4x plus blank equals 8 plus blank. Then we need to find our magic number. Your magic number is b, which is negative 4 over 2 squared. What's negative 4 over 2? Squared. Positive 4. Very good. So we get 4. 4 is our magic number. Told you it wasn't always going to be 9. It just so happens that the first 3 were 9. Okay? So what do we do next? Factor it. Parentheses squared. What's the square root of x squared? What's the square root of 4? 2. Is it a plus or minus? Minus. Equals, what's 8 plus 4? 12. What do we do next? Square root both sides. The square root and the square cancel each other out, and I get x minus 2 equals plus or minus the square root of 12. Does the square root of 12 simplify, guys? Yes, what is 12 divisible by that's a perfect square? Let's make a list of our perfect squares on the board. What's 1 squared? But do we need to really do that? No, because everything's divisible by 1. What's 2 squared? What's 3 squared? What's 4 squared? 5 squared? 6, 7, what am I at? 8, 9, 10, 11, and 12. We'll stop there, okay? So whenever we're simplifying our radicals, we're looking for if my number is divisible by any perfect squares. Is 12 divisible by any numbers on my list? 4. So I'm going to rewrite this as x minus 2 equals plus or minus the square root of 4 and the square root of, because 12 divided by 4 is 3. We did do this a while back. We did this before Christmas break. Does that kind of ring a bell? You're finding the perfect square that your number is divisible by and separating it into 2 perfect squares. Sorry, 2 square roots. The perfect square first, the non-perfect square second. So x minus 2 equals plus minus. What is the square root of 4? 2. 2 square root 3. We go with that? That's how you simplify the square root of 12. Okay? Now we're going to solve for x. What do I do to get x by itself? So I get x equals. When I add 2, can I do 2 plus 2? Are these like terms? No. This 2 has a root 3 attached to it. Does this 2 have anything attached to it? No, so you can't combine them. So this just becomes 2 plus minus 2 root 3. Think of them as this radical being a variable. If this was 2x, you can't combine 2x with just 2. Okay? Think of that radical as like a variable. The radicals must be the same to be able to add them together. Okay? Done. Now again, guys, if you're like still confused by this, it's really okay. Okay? It's really okay. Because do you ever have to use this method? No. Okay? 2 more. Then we're done. And you'll be done with math for or math lessons for 12 days. I think I don't see y'all for 12 more days. You sure make sure you sign out when you leave, okay? So sign out, sign back in. Okay, this time, guys, does A equal 1? No, you have to have A being 1. So I'm going to divide out -3. To get rid of the A being -3, you divide out a -3, right, Dominic? If A is not 1, you divide out whatever A is. So -3 over -3 cancel, and I just have x squared. What's 24 over -3? -8x, very good. And then what's -42 over -3? What is it? Positive 14. Negative is a positive, and you get positive 14. What's 0 divided by anything? 0. Now is A 1? Yes. Okay, I need to move my C over. So I'm going to subtract 14 on both sides. So I get x squared minus 8x plus blank equals -14 plus blank. What do I need to do next? Before I factor, I need to find the magic number. Very good. Find the magic number. I need to know what goes in those blanks. Again, your magic number is b over 2 squared. What's b? -8 over 2 squared. What's -8 over 2? -4 squared is 16. So my magic number is 16. Very good. Now we factor it, because I just made it a perfect square trinomial. Guys, again, that's what finding this magic number does. It makes it to where this will always be a perfect square trinomial. So before, when we did factoring, and I was like, you have to check and make sure it's a perfect square trinomial. Here you're not checking, because we are making it a perfect square trinomial. It will always be a perfect square trinomial. Okay, so parentheses squared. Square root of the first goes first, square root of the last goes last. Is it plus or minus? Minus, and it equals 2. Okay, what do I do next? Square root. Square root, gone, gone. So I get x minus 4 equals plus minus square root of 2. Don't forget the plus minus square root of 2. Then I need x by itself, so what am I going to do? Add 4. When I add 4, can I actually add these together? No, they're not like terms, so it's just 4 plus minus root 2. If I were to write this as an ordered pair, I'm going to do 4 plus minus root 2, comma, 0. Again, how many solutions are here, guys? 2. 4 plus root 2, 4 minus root 2. Good? Are we okay not doing the last one, guys? Yes? Okay, start doing your homework. If you have late work, you need to get late work done first. Although I think I closed